Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all the four problems asked in today's LeetCode Weekly Contest 467. So let's start with the first problem. It says you are given a 2D integer array task where each task contains two information S and T, right? And for each task, your S of I indicates the start time and T of I indicates the unit of time it takes to finish. And we have to return the earliest time at which at least one of the tasks is finished, right? So for each of the tasks, we know that the start time is S of I and the duration of the task is Ti, right? So the in time would be Si plus Ti, right? So for each task, we know the in time and we have to return the earliest time in which at least one of the tasks is finished. So the like so in this problem we just have to find out the minimum in time of any of the tasks. For example, here your in time is 7, the in time is 5, so this task would be finished earliest, right? So this will be the earliest task which will be finished, so the minimum time would be 5. Similarly here, 200, 200 and 200, so anyway the minimum is 200, right? So yeah, this is a just like pretty one line problem. So here is the code. uh, this is my answer int max. Now I'm going through each task and your answer is equal to minimum of answers comma in time, and we know the in time is start time plus duration, right? And just return the answer. So yeah, this is the first problem. Now let's look at the second problem. In the second problem, it says you are given a positive integer array nums and an integer k. You have to choose at most k elements from the nums array so that the sum is maximized, right? So we have to choose the at most k element so that the sum is maximized. However, the chosen number must be distinct. Okay. So and we have to return the array containing all the chosen number in strictly decreasing order, right? So here for example we have to choose at most k numbers such that the sum is maximized. We it's obvious, right? If you want to get the sum maximized, start choosing from the maximum elements, like from the nums array. So here the max element is 100, so choose 100 because you have to anyway make the sum maximize. So 100 is one. The second maximum is 93, choose 93. And then the third max is 90, so choose 90. So yeah, this is your three elements which you have chosen, right? So these three would give you the maximum sum because these are the maximum numbers present in the array. And let's take this example. So here you want to choose three numbers, so 100 is the maximum one you have chosen. Now 93 is the second maximum which you have chosen. See, the third maximum is again 93, but you cannot choose this because we have to choose the number in a distinct way, like all the numbers should be distinct, so we cannot choose 93. So now go to the next maximum which is left, which is 84, so choose 84, right? So this is also a implementation problem. Let's see how we can write code for it. Here is the code. This is your nums array, this is an integer k. So I have taken set. So set will do two things. It will first keep all the unique numbers, and the second thing, it will be in a sorted order, right? So yeah, and then what I did, I sorted the given nums array, right? Now what I'm doing here, I am taking the maximum element from the nums and I am keeping it into the set. But there are two things which needs to be checked. First, your nums shouldn't, so this while loop should only be running until your nums not become empty, right? Now the second condition, your set dot size should be less than k, right? Because we know that we can keep at most k number of elements, like we can choose at most k number of elements. So yeah, these two conditions, if both are true, choose the maximum from the nums array, remove it, and insert it into the set. That's it. And at the end, at the end your set would contain all the k distinct number, I mean the maximum numbers, k maximum distinct numbers. So just return them, like but remember we have to return the numbers in decreasing order. So I have used st dot r begin and st dot r end. So yeah, this is the code of second problem. Now let's look at the third problem. The third problem says you are given an integer array nums of size n and a positive integer k. Now an array capped by value x is obtained by replacing every element nums of I with minimum of nums of I comma x, right? The minimum of x and nums of I. Now for each integer x from 1 to n, you have to determine whether it is possible to choose a subsequence from the array capped by value x, right, such that the sum of the chosen element is exactly k, right? And we have to return a 0 base indexed boolean array where answer has the same size n, and answer of I is true if it is possible when using x is equal to I plus 1, right? So I is a 0 base index, so for each x from 1 to n you have to determine this answer array, right? So where answer of I is equal to true if it is possible to choose a subsequence that is capped at this x value and the sum of the chosen number is exactly k, right? And false otherwise, right? So yeah, this is a good problem. Let's see how we can approach it. This third problem is pretty much similar to this problem. I would highly recommend to solve this problem first. This is also one of the famous problem asked in multiple interviews. So for this problem, essentially uh, what it does, it essentially finds all the subsequence that has the sum equals to k, right? The problem asked in today's contest is a slightly harder version of this problem, but the sole concept is going to be the same, right? So we will here also we will use a dynamic programming approach where, so it will be a 1D DP, and where DP of I is true if it is possible to choose a subsequence from the array such that the sum of the chosen element is exactly I, right? Now we know that, so let's say this is my given array. Let's say this is my given array, right? So the first job is to sort the array. So after sorting, let's say the array looks like 0 1 2 3 and so on, right? And now what we will do, we will since we have to cap this given array for each of the number from 1 to n, right? So we have to first cap by capped by 1, then 2, then 3, right, till n, right? So we have to cap the array. So let's say for a given number I want to cap this number by I, right? So once you cap by I, the array would look like, so initial few numbers are going to be the same, and after some point your all the numbers would be I, because once you capped the number, your number is would be replaced by I for those number which is greater than I, because we have to replace with the minimum of that number comma x, right? So this is how your array would look like after capping. Now the job is easy, right? So now I will go through all the numbers here. So let's say my current number is v and the previous number, so I will go through all the possibilities of the previous number. So let's say this is my previous number x, right? I will first check if dp of x is 1 is true. If dp of x is true, means that I can get, like I can choose some of the elements such that the sum of those number is x, right? So if that is true, then dp of x plus v is also true, right? Also true, because I can, since it is possible to get x, right? So since it is possible to get x, I can easily get x plus b by choosing this number and the previous subsequence of these numbers such that whose sum is equal to x, right? So this is for these numbers. Now for these numbers, what we will do, we will again follow the same approach for these numbers, right? And once you do that, just check if it is possible to get dp of k or not. If it is possible to get dp of k by capping at that I, if it is true, your answer, just insert true to your answer, otherwise return insert false, right? So yeah, I hope you understand this problem. So let's now look at the code. Here is the code. This is a given array A. This is my integer k. This is the size. I have sorted it first. I created a 1D DP array of size k plus 1, where DP of I equals to true if it is possible to choose a subsequence from the array such that the sum of the chosen element is exactly I, right? So initially DP of 0 equals to 1 for empty subsequence. This is my answer. So this is a variable called P. So P will tell you the partition. So T will tell you the, so let's say I'm at index I. So this is the partition, like after, like beyond it, all the numbers are I, and before that, all the numbers are 0, right? So now I'm going through all the numbers I from 1 to n to cap. So because we have to cap each of the number by I, right? So now I want to cap the number by I. So I will first find the partition, the P here. Beyond that of the all the numbers are I. So while P is less than n and A of P is less than or equals to I, right? So if the number is less than or equals to I, that number is going to be the same, like because we have to, so capping means change the number to minimum of that number comma I, right? So if the number is still less than I, just that number would be the same as present in the original array after capping, right? So this is the array after capping. So this is my current number V, A of P. Now what I am doing here, I am just updating my DP. So for all, so if you take it, your minimum number is going to be V, and we have to build the DP for maximum K, right? So for J equals to K, J is greater than or equals to be J minus minus. If it is possible to get J minus V, like if DP of J minus V is true, your DP of J is going to be true, right? Because if J minus V is true, then it means that we can get a subsequence such that the sum is equals to J minus V, and I can just add this number, and once you add this number, your total sum is J. So DP of J is 1, then P plus plus, that's all. So this will give you the partition P. Now we know the partition because after partition P, all the numbers are I, right? Now what I'm doing here, this is my remain. So this is my answer, whether this is true or false. This is my remaining numbers. Remaining numbers are total minus P, right? So total minus P is the remaining numbers. Now, now what I'm doing here, I'm going through all possible sums which you can get by taking those remaining I numbers. So for J equals to 0, J is less than or equals to remaining numbers, and this J into I, right? So if you take this number J number of times, right? So since the count of those numbers are remain, right? So either you take 1 or you take none or you take all. So at max it can go till remaining. If you take, let's say if you taken J number of times I, then that if your J into I is less than or equals to K, right? Because I know that all of my number is are I, all the numbers are I, right? So J is the count, I is the number. If that is less than or equals to K, just check if your DP of K minus this is true. If this is true, means that we can get a subsequence such that the total sum is K minus J into I. And if that is true, I can take as many J number of times I, and I can get the total sum K, right? So total sum K, if you can get the DP of K, then your F is going to be true. You can get the sum exactly K by capping at I and just break it, and at the end return, just insert this answer, this true and false, whatever your answer is, to the answer array and return the answer, right? So if you submit it, it is accepted, right? So yeah, this is the third problem. Now let's look at the fourth problem. Fourth problem says you are given an integer array nums and a subsequence is called stable if it doesn't contain 3 consecutive elements with the same parity when the subsequence is read in order, right? So if you start reading those subsequences from left to right, none of the three consecutive elements should have the same parity, right? And we have to return the number of stable subsequence, and we have to return the total answer modulo 10 to the power 9 plus 7, right? uh, yeah, this is really a good problem. Now let's see how we can approach this problem. In the fourth problem, we have to find out the number of stable subsequence, right? And a stable subsequence should not contain three consecutive elements of the same parity, right? So whenever in a problem, we have to find out number of ways, mean and max, and there are multiple ways to kind of to build the state. So those problem are, I mean, 90% of the time are solved as a dynamic programming problem, right? So in DP problem, we always try to find what information is important so far, what information which you store, so that you can build the state for the bigger problem, right? So uh, what information we required, so let's say this is my current number I, right? This is let's say a of I, right? I want to put this number in the subsequence, right? So so what information is important so far? I don't care about all the numbers in the previous so let's say I want to add this current number a of I to be a part of subsequence. Do I care about all the numbers like which are present previously? No. I just care about the last two numbers. Actually, not even the numbers. I just care about the last two parity. Let's say this is P1, this is P2. That's all I care about, because we have to just take care that none of the three consecutive numbers should have the same parity. I know my current parity. I just care about last two parity. That's it. Nothing else, right? So this is how you get the state of the DP. So your DP state should be DP of n 2 2. So DP of I, so let's say DP of I P1 and P2. We have DP of I P1 and P2. So DP of I P1 P2 means the total number of stable subsequence, total number of stable subsequence, total subsequence such that total number of actually total number of stable subsequence from index 0 to I, right, such that the last two parities, the two last parities are P1 and P2. That's it. Problem is solved. So in DP, if you build the correct state, the problem is almost solved, to be honest, because after that you just have to like configure all the cases, like how to build DP of I, P1 and P2, right? So yeah, this is the state. Please think about it. I just care about the last two parities, nothing else, right? So this is my DP of I, P1 and P2. Now let's see how we can build this DP of I, P1 and P2, right? By now, I think we all have understand that what should be the state of DP. The state of DP is DP of n to 2. It's a 3D DP, where DP of I, P1 and P2 means the number of stable subsequence from the numbers between 0 to I, such that the last two parities are P1 and P2, right? So now let's build the DP, right? So the first case is, let's say, so you will be given a nums array, right? So let's say that the size of the array n is equals to 1, right? In that situation, your answer would be just 1. Take that number itself, right? So second case, if your n is equals to 2, right, in that case, what should be your answer? Your answer will be 3. So there are three ways, right? Because since the number are even less than 3, so there is no point of checking this condition that three numbers should have the same parity. It's not possible to get even three number for n equals to 2 and 1 and 2. Now the last case, if your n is greater than or equals to 3, right? So here we have to build the state of the DP, right? So if n is greater than or equals to 3, right? So we will first so let's say this is my given array nums, right? This is my nums array, right? And I am current index I, and this is my I minus 1, I minus 2, and so on, right? And I have already calculated my dp till I minus 1, right? So I know dp of I minus 1 0 0, I know dp of I minus 1 0 1, right? I have, let's say, build all these cases 1 0, and dp of I minus 1 1 1, right? Let's say I know all these four information because at the these two places only these four combination are possible: 0 0 0 1 1 0 1 1, right? Now I want to build the dp of I. Let's see how we can do it. So there are two cases: either the parity of correct number is 0 or 1, right? So let's take case 1. If the parity of correct number is 1, right? If the parity of correct number is 1, right? In that situation, what will be your dp of I minus 1, sorry, what will be your dp of I 0 0, right? I want to get dp of I 0 0 0 0 1 1 0 1 1, right? In that situation, since the current parity is 1, the current parity is 1 means that you cannot put this number at the end, right? Because if you put current number at the end, your parity is going to be 1, but we know that we have to find out the parity is 0 at the end. It means that we cannot keep this number, like we cannot insert this number into the valid subsequence, right? So in that situation, your dp of 0 0 is equal to simply dp of I minus 1 0 0, because we cannot take this number. Similarly, dp of I 1 0, it will be dp of I minus 1 1 0, because we cannot take this number. Now comes to the third, dp of I 0 1. Now there are two things: either since the last parity is 1 and my current parity is also 1, this is my p2, right? P2, right? So in that case situation, you can either take it or you don't take it. So there are two cases. If you don't take it, dp of I 0 1 is going to be dp of I minus 1 0 1. If you don't take it, blah, plus if you take it, it is going to be dp of, since we know that none of the three consecutive elements have the same parity, I know I am taking this number, so my current parity is 1. What are the possibilities of these two parities? It could be either 1 0 or 0 0. The reason is because we want to build a state for dp of 0 1, right? So this is my p2 and this is my p1, right? So p2 is 1, so p1 should be 0, right? So the only possibilities we have to change here, one, either it could be 1 or 0. So dp of I 0 1 is equal to dp of I minus 1 0 1 if you don't take it. If you want to take it, there are these two only possibilities we have at the previous parities, right? It is dp of I minus 1 1 0 or dp of I minus 1 0 0 0 0, right? Yeah. And just one more thing, just the last case, since we know my current parity is 1, right? We know my current parity is 1, and at this place this number should be even, right? The second last number should be even in the subsequence, which you are building by taking this one. So this plus total number of even numbers so far, total number of events number like before I, right? Because we want, because here we have configured these two numbers are present, right? Like the previous subsequence have at least two numbers, like during dp of I, p1 and p2, like. But it might be possible that but in a subsequence it might be possible that this is my current number and you take any one of the previous numbers, right? So that case is not configured in dp, so just plus even. This even means you take any even number from 0 to I minus 1 and you kind of combine that with the current number, right? Because we want to build the state for dp of I01, and so the number is already odd, so just you have to find out the total number of previous even numbers. So yeah, this is the dp. Now the last one is simply dp of I11. So this is going to be dp of, if you don't take it, this is going to be dp of I minus 1 1 1, and if you take it, this is going to be dp of I minus 1 0 1, right? So why 0 1? I know my current state, like my current parity is 1, my previous parity should be 1, so 1 you should also be 1, the previous parity. Now what are the possibilities here? See, now this parity should be only and 1 and only be 0. If you are keeping this as parity 1, then what essentially you are doing, you are making three consecutive numbers having the same parity. So at this place only one possibility is there, to keep only 0. That is why dp of I11 is dp of I minus 1 1 1 plus, if you don't take it, and if you want to take it, take the, like if you want to, taking means like keeping this correct number into the subsequence, right? Then dp of I minus 1 0 1, that's the only possibilities. Now again same, the last case, so I want to keep this current number, right? So previous parity should be 1 plus total number of odd elements so far. That's it. Yeah, that's all the state. I would highly recommend to similarly calculate for case 2. Case 2 is when the current parity is 0. Now try to build all these four dp of I00 0 1 0 0 1 and 1 1 for the case when your parity is even, because this was the parity, so this was the case when the parity was odd parity, right? Yeah, I hope you understand it completely. If you have any question, please write a comment. So yeah, please highly recommend, like I would highly recommend to write a state of dp by yourself for case 2, like you would understand completely. Yeah, let's see the code for it. So here is the code. This is my nums array, this is my size. So if n is less than or equals to 2, just return 2 to the power n minus 1. Simply means if n is equal to 1, it would be 1, and for n is equal to 2, it would be 3. Now I have created a dp array, 3D dp array, dp of n 2 2. So dp of I, p1 and p2 simply tells number of subsequence from 0 to I such that the last two parities are p1 and p2, right? Now what I have done, I have built the corner case. The corner case is dp of 1 nums. So this will give you the parity. If you do AND bitwise AND with 1, it will give you the parity. So dp of 1 nums of 0 and 1 nums of 1 and 1 is going to be 1. This is my base case, right? I have calculated how many even numbers we have and how many odd number we have for index 0 and 1, right? Now I want to build the state of the dp for like from index 2 to n. So there are two cases I discuss. First case is my current parity is odd. The second case when my current parity is even. Now let's look at the current parity. Like if your current parity is odd, we know that we cannot take this number. If you take this number, your last parity is going to be 1, but we don't want that. Like during calculation of dp of 0 0 and 1 0, because here I have claimed that my last parity is going to be 0, so we cannot take this number. So in that situation, your dp of I 0 0 is simply I minus 1 0 0, and dp of I 1 0 means dp of I minus 1 1 0, right? Now for dp of I 0 1, so there are two cases: either you take it or you don't take it. If you don't take it, it's dp of I minus 1 0 1, plus if you take it, right, if you take it, the last parity is going to be 1, which I have already taken. Previous parity is fixed to 0, right? So the only possibilities to change is the second, like the third parity. So it is either 0 or 1. So dp of I minus 1 0 0 plus dp of I minus 1 1 0. Please check out the explanation part I have explained there. Plus total number of events. I can make a pair of, so I can make a subsequence of two number having this number at the second, at the last, and the previous any of the even numbers, because I want to I want to have my second last number having the parity as 0. So this is even. Similarly, dp of I 1 1 is equal to, if I don't take it, dp of I minus 1 1 1, plus if you want to take it, we know that my current so like if I take it, my last parity is going to be 1 for sure, right? And I want the second last parity is also to be 1. But so what are the possibilities you have? The third number could have either parity 1 or 0, but you cannot take 1, because if you take 1, the three consecutive number is going to be have the same parity, so it should be only 0 and 1, dp of I minus 1 0 1, plus odd, same explanation. Like you can make a valid subsequence of having two number, such that the last number is this number a of I, and the previous number could be any of the odd number. Yeah, and if this current number is odd, just increment odd plus plus. Exactly same for even, just a vice versa case. So since my current parity is 0, I like to build 0 1 and 1 1. I cannot take this number, so this is simply going to be I minus 1 0 1 and I minus 1 1 1. Now if my current parity, so now we know that my current parity is 0, I want to calculate dp of 0 0 1 0. So it means we can either take it or don't take it. If you don't take it, simply I minus 1 0 0, plus if you want to take it, I know my current parity is 0, my previous parity should also be 0. Now what are the possibility at the third place? It can only have one parity, and that is 1. That is why I have taken dp of I minus 1 1 0, right? And same, we can form a valid subsequence of two numbers having this number at the end, and the previous number could be any one of the even numbers, right? Same for dp of I 1 0, right? So if you don't take it, I minus 1 1 0. If you take it, 0 1 plus 1 1, and the total number of odd numbers, right? And just take the modulo at the end. Now since this is a even number, so this is an even number incremented to even variable, right? So at the end, my initial answer is n means take all the single numbers, take all single numbers, right? So let's say you are given nums array of size n, so you can, so taking one number is also a valid subsequence, right? So this is my n. Now for at the end, like for numbers greater than or equals to 2, use it from the dp array. So this is going to be dp of I n minus 1 0 0 0 1 1 0 1 1. So here I have taken, I mean, for that reason I have taken two for loop. 0, like the first parity could be, so so this is my p1, this is the parity of p1, and this is the parity for p2, right? So yeah, and your answer is going to be sum of dp of n minus 1 p1 and p2 could be either 0 0 1 0 1 0 0 1 and 1 1, right? And at the end return the answer. Yeah, this is all about the explanation part and the code for the fourth problem. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.